Welcome to question 6 of the 2013 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAR. So for question 6, let G have a domain of all real numbers with the rule g of x equals a subtract x squared, where a is a real constant. The average value of G on the interval -1 to 1 is known to be 31 on 12. And we are asked to find all possible values of a for this question. So even though it's not on the formula sheet, you need to know that the average value for a function on the interval a to b is 1 on b subtract a, so the length of the interval, times by the integral between a and b of f of x dx. So therefore for this question we're going to have 1 divided by, and the interval is going to be 1 subtract -1, so it's got a length of 2, times the integral between -1 and 1 of the function. And now we are going to expand this because it's a quadratic, so it's not too bad to do. So we have g of x is equal to, and this is going to expand to give a squared minus 2ax plus x squared. So in our integral we're going to have a squared minus 2ax plus x squared, and the function's variable is x and a is just a constant, so we're going to anti-differentiate with respect to x, and we know that that is equal to 31 divided by 12. Therefore in our next line of working we're going to have 1 divided by 2 multiplying the antiderivative, which, because it's with respect to x and a is just a constant, we get a squared times x. And for the next term we add 1 to the power of x, so we get minus 2ax squared, and then dividing by the new power just gives minus ax squared, and then we'll have plus x cubed on 3. And that's still going to go between -1 and 1, and we know that it's going to equal 31 on 12 still. Now multiplying both sides by 2 to get rid of the half, we get that this is going to equal 31 on 6. And now to evaluate this antiderivative between -1 and 1, we're going to substitute in the upper terminal first. So we get a squared times 1 is simply a squared. And then we have minus a times 1 is just a. And then we get plus 1 cubed over 3, which is plus a third. And then we subtract away the antiderivative with -1 substituted in. So we're going to have negative a squared as our first term. And then we're going to have negative a times -1 squared is just negative a. And then -1 cubed is still -1, so we have -1 over 3. Now we just look to simplify this as much as possible. So we're going to have a squared subtract -a squared will give 2a squared. Then -a subtract -a will actually be -a plus a, so they will cancel. And then we'll have 1/3 subtract -1/3, which will give us 2/3 on the right hand side. And we know that is equal to 31 over 6. And now our job is to solve this equation for a. So we're going to start by subtracting 2/3 from both sides, which is the same as subtracting 4 on 6, just so we have a common denominator. So therefore we find that 2a squared is equal to 27 on 6. And then dividing both sides by 2, we get a squared is equal to 27 on 12. However, that can be simplified down to a squared equals 9 over 4. So therefore, a must equal plus or minus the square root of 9 over 4, which is 3 over 2. So they are the two possible values for a for this question. From the examiner's report, we can see that 16% of students got full marks for that question, with 40% of students getting no marks for the question. Most students attempted this question, but far too many misunderstood the average value to be the average rate or average of. And the examiner goes on to say that the correct antiderivative of the bracketed form of g of x was less evident, which is this left-hand side here of the examiner's working. It was less evident than the expanded form due to the necessary division by the coefficient of x. So the expanded form, which we did on the previous slide, is detailed here. And that's just summarising that more students made errors when it was in bracketed form rather than expanded form. And furthermore, it says that the formula for the average value was not on the formula sheet and it won't be on subsequent exams. and that students should ensure they have a good understanding of the concept that the average value of a function over an interval a to b is given by 1 divided by b take a of the integral a to b of f of x dx. So that's a formula and an understanding that students should have for this course.